Hello, the purpose of this video is to show how to get Bitwig to be able to output NRPNs. And I'm doing that because I'm going to map CCs to NRPMs through software called Bome. So this is Bome here. I forget the price. It's pretty reasonable. All right. So just as an overview, I'm just going to show you here in the Prophet 12, which is the hardware synth I want to control. This is its manual, and it actually shows the NRPNs, non-registered parameter numbers, and I need 7 and 519. Prophet 12 has two layers, so and they have separate NRPNs. You'll see that the value is showing a 0 to 255, so that will not fit in 7 bits. So therefore, they have to send 14-bit NRPNs to control these parameters. So keep that in mind that I'm basically going to go from a 7-bit CC to a 14-bit NRPN, and I'll show you how I do that. Okay, so the setup from the Bitwig perspective is I'm going to route out to Bome MIDI Translator 1, which Bome provides. So all my outgoing MIDI is going into Bome through Bome MIDI Translator 1. And I'll show you how that works when I bring up Bome. So that should be pretty much it. I've set up the two CCs using this MIDI CC, and they're both controlled by a single controller on my Minilab 3. Okay, and there's two controllers just because there's two layers on the Prophet 12. It's just the way it is for that particular synthesizer. Okay, so in Bome, I have a project, I have a preset. There's just one, I just have this one preset. I don't need to switch multiple times. So the first thing to maybe pay attention to is there's this MIDI router. It's up here in the upper right, show project MIDI port settings. And I am routing Bome MIDI Translator 1 virtual into DIN3 and DIN3 back to Bome MIDI Translator. So Bome is the middleman in this case. So now I just need to add some routings. I have two routings, one for each NRPN. I'll show them both, but I'll focus mainly on the first one. They're very similar. The incoming will be a MIDI message control change on channel 14, and CC will be 20. That's hex 14, hexadecimal 14. And I set a variable called OO, which is in this drop-down list here. So that is capturing the incoming value of the CC into this variable called OO. The next thing I do is in the rules section, I'm going to do some math to convert the 7-bit to the 14-bit. So I'm just going to multiply by 256 and divide by 128. Basically, that's just standard how you convert something. You you know you could think about it as I'm dividing by the incoming value range and multiplying by the outgoing value range, except I flip it around in case these are integers. That's just some programming stuff, because if it doesn't do floating point numbers, it's going to be all kinds of wrong. So because I didn't know that, I simply do it the opposite way. I multiply by the output and then divide by the input range. And then I create a new variable called PP. And then in my outgoing, I say I want a 14-bit NRPN on channel 14. The MSB 0, the LSB is 7. That's the 2 bytes of the 14-bit message. MIDI is, because of how MIDI works, the data values they're stored in a byte, but they're only using the low 7 bits. So the range is 0 to 127. So you need 2 of those 7-bit ranges to make up a 14-bit range. There's a bunch of stuff online explaining this somewhere, I'm sure. But anyway, the key point here is the value is PP. So the outgoing message is PP. And I should be able to show that translation. I'm turning the control and I'm capturing in this log message. Let me just take an example here. Here's an incoming control change 14 CC20. It sets OO to the CC, And then I do it's showing the rules here because I've clicked in the log that show me the rules. And I multiply, let me just take something that's more interesting here. I multiply 00 by 256 and divide by 128 to get 6. If I turn this all the way, oh, wrong knob, the last thing I see should be a pretty big value. 00 is 127, and I multiply it to get 32,512, and then divide down to 254. That's about right. That would be the top value. Okay, so that is how I do it. And the second one is the exact same, except CC21 and the MSB is 2 and the LSB is 7. This is 519. That's 2 times 256 plus 7, 519. All right, so you won't be able to really hear this very well, but if I just play a note and I twist this, I'm getting a frequency modulation oscillator. So that's it. That's how you do it. You can get around this annoying limitation in Bitwig that it does not do NRPNs. Thanks for watching.